Hello everyone, welcome to my channel. In this video we are going to understand how a NOR gate works using NPN transistors. First, let's look at the components used in this circuit. We are using 3 batteries, 1 LED, 3 resistors, 2 NPN transistors, and 2 switches. Out of the 3 batteries, 2 batteries are used as the inputs of the NOR gate, and the third battery is used to power the circuit. The LED in this circuit acts as the output indicator, so we can easily see whether the output is high or low. The resistors are used to limit the current and properly control the base current of the transistors. Before we understand the circuit, let's quickly see what a NOR gate is. A NOR gate is a digital logic gate that gives an output of 1 only when both inputs are 0. For all other input combinations, the output becomes 0. Now let's see how this circuit works. In this circuit, we are using 2 NPN transistors connected in parallel. The collectors of both transistors are connected to the LED through a resistor and then to the supply battery. The emitters of both transistors are connected to ground. The base of first transistor receives input A through a resistor and a switch after. The base of the second transistor receives input B through another resistor and another switch after. Now let's check the different input conditions. First case, when both inputs are 0. When both switches are open, no base current flows into either transistor. This means both transistors remain off. Since both transistors are off, there is no path for current to flow to ground through them. Because of this, current flows through the LED and the LED turns on. This means the output is 1. Second case, when A is 1 and B is 0. When the first switch is pressed, the first transistor receives base current and turns on. Now a path is created from the LED through the transistor to ground. Because of this path, the LED turns off and the output becomes 0. Third case, when A is 0 and B is 1. Now the second transistor turns on while the first one remains off. Again, a path to ground is created through the second transistor, so the LED turns off and the output is 0. Final case, when both inputs are 1. Now both transistors turn on. Since they are connected in parallel, current easily flows through transistors to ground. Because of this, the LED turns off and the output remains 0. So the LED turns on only when both inputs are 0. For all other input combinations, the LED turns off. This behavior matches the operation of a NOR gate. If you look at the graphs in the simulation, you will see 3 waveforms. The first graph represents input A, the second graph represents input B, and the third graph represents the output, which is the LED. We can also verify this using the truth table. When A and B are 0 and 0, the output is 1. When A is 0 and B is 1, the output becomes 0. When A is 1 and B is 0, the output is also 0. And when both A and B are 1, the output remains 0. This confirms that the circuit is working as a NOR gate. Thank you for watching. And don't forget to like, share, and subscribe for more electronics explanations.